Welcome to Commsverse. This session is called Cracking Open the Black Box, How to Troubleshoot Teams Core UC Workloads. And today will be presented to you by Carolyn Blanding. Over to you, Carolyn.
Thanks, Dave. Welcome, everyone. For those of you who don't know me, my name is Carolyn Blanding. I'm a Teams data escalation engineer at Microsoft, and that means I get to spend a lot of quality time diagnosing Teams issues. And I hope to share some of my tips and techniques with you today. And I also want to show you that the answers lie within your reach. It's not really a black box once you know where to look for things. Let's get started. We're going to look at our core UC workloads today: chat, calling, and presence. And we'll start with chat. Have you wondered, how does Teams make those decisions for those client threads? There's different types of threads: when, why, and how. First, before we start looking at the diagnostic information, it's important to understand the types of threads that are created and why. When we have a thread between two users within the same organization, those would be internal threads. Those threads will always be a Teams native thread unless the target user is an SFB mode user. So Teams native unless target is SFB mode. When we're talking about external threads, that's threads between users in two different organizations, an external thread. Those threads will always be an SFB interop thread unless both users are Teams only. If you bear in mind those two simple rules, it makes understanding thread creation a lot easier, especially when you see a change in thread between one type of thread and another. Now let's dive under the covers and take a look at how Teams is making these decisions and where you can look to see that happening. I have here a Teams client open, and we're going to examine each of the different threads that I talked about, interop thread, native thread, within org and external threads, and then see how Teams made that decision to set up those threads. Our first thread here is an SFB mode, interop mode thread with an SFB mode user in org. Our next thread is an SFB interop thread. We have an external conversation going with another user. We don't know their mode, but they're not Teams only. The next thread is a Skype for consumer thread, and you'll notice the white S background. That's a Skype consumer thread. That will also be interop. We only do native thread with consumer users if they're using the Teams for Life client. And then finally, we have a native thread with an external user. This is a Teams native thread. Now I've downloaded the Teams logs using Control-Alt-Shift-1 so that we can examine the diagnostic information about this. Those files will be down in the downloads folder, and I'm opening the diagnostic logs, and I'm opening them with the tool called Visual Studio Code. I'll show you some tips today with using Visual Studio Code, and you might like to use this for your own log reading as well. So I have the log open, and I'm opening a search folder, a search view, and I'm turning on regex. So I clicked on the *.star so I can kick off a regex search. And in this case, I'm not exactly sure what to search for, but I know I'm searching at diagnostics about chat, and I know that it pertains to mode. So I'm looking for a phrase that starts with chat followed by mode. And right away, I found something interesting in the file. I can see the conversation service get private chat user MRI. So let me replace this with a more precise search and open the results in an editor view. So now I have these particular results out in the editor view. And we can see on the right, we'll examine the paired conversations between the two users. The logs read from bottom up. So the last thread we clicked on was the one with the native federated chat. It's the first that we see in the event log. And we can see there that we have a conversation between the Teams user, the sender, and the external user. And it's a native federated chat thread. I've highlighted the org ID for the sender so we can see that sender in each of the pair of conversations. Let's look at the next thread, which was with our Skype consumer. And we can see there that Skype consumer thread and the Teams native thread user. And then we're looking at a federated thread versus a native federated. This is an interop thread with our external user, Alex. And then finally, let's take a look at the in-tenant interop thread. Here we see it's an SFB mode user. Again, SFB mode will dictate that we have an interop thread when it's within org. What this particular search didn't show us was what the actual modes were for the federated users. We could surmise the native, but we couldn't really tell for the other user. So doing another search here, get user chat mode .star federated, and output that to the editor, and that will get the details of the mode for both of these federated users. And we can see for me, Teams only. For the other user, it was islands. It wasn't SFB, it was islands. Again, interop thread will between org tenants will always do interop unless both users are Teams only. To recap, to confirm the type of thread that's used and to see the diagnostic information in the client, we can download the client logs using Control-Alt-Shift-1, open them up in a text editor. If we're using Visual Studio Code, we can use a regex expression. We're not quite sure what to start with, so we'll cast our net wide. This is how I do all my research. I don't always know what I'm looking for, especially when it's a new feature. I don't know what the particular diagnostic codes will be. And then once we have a more refined search term, we can use that and open our results set in the editor view so we can scope our results to just what the information we need to investigate. And again, to see that federated chat modes, we can search for get user chat mode followed by the word federated and see the modes for those users. Okay, now we've seen how Teams client determines what type of chat thread. How does Teams client find the mode for the user? Well, it finds the mode for the user through the local cache copy of the people service database. So this database is cached locally on the client, and the Teams client uses that to find the user's mode. Let's take a look at that in action. I have the Teams client open here in a browser window, and what I'm using the browser, this is Edge browser, and I'm opening the developer tools so that I can actually view the application database that the client is using. I'm opening the application tab, and I've already navigated to the index database, the user principal name. And let's go ahead and look at each of these users and see the details about them. Our in-tenant work user, Anne, is a SFB with Teams collab user, hence the interop thread. Our external user, Alex, as we saw before in our diagnostic search, is a federated user, and we see his mode as islands. And in our next thread, which is our Skype for consumer thread with myself, my Skype consumer client, you'll see that it's a Skype consumer. And note, the email address is not stored in the people service database, and that's legally for privacy reasons. We don't store the email address. And then finally, if we look at the My User account at Microsoft, we'll again see this is a federated user, in this case, with a coexistence mode of Teams only. So the Teams client determines the type of thread based on the user's mode, and it gets the user's mode from the local cache database, which is stored in the user's roaming profile. We can clear that cache database by signing out of the Teams client. A sign out of the Teams client will clear the cache, as we can see here, and a sign back in will refresh that database. The database itself will refresh every 24 hours automatically on a skew based on the time that a client logged in. For those of you who've done diagnostics with Skype for Business on-prem server, you might remember the Contacts DB works similarly. To recap, the Teams cache people service database on the local client is used to look up users' coexistence mode to determine the chat thread. We can view that in the application tab of the developer tools, and we can drill down under the user's value to the feature settings to see the coexistence mode. We can clear this database cache by logging out of the client and signing back in. Now, a quick investigation, now that you know where to look and how to look. Here we have a user who's sending an external chat. An interop thread, we can see the user's available, but the message failed to send. What do? We download the logs. Do a search. You can do a regex search, war.sfb. I did .star-SFB. I actually just searched on SFB. It came right up. And now, of course, we know that it's an SFB interop service gateway. We see an error code 488-52033, but we didn't get a reason phrase. A quick internet search of that reason diagnostic comes up with the phrase, incoming conversations are blocked over federation link. That means this particular on-prem server user has a client policy that's blocking unsolicited federated chats. And therefore, unless that user adds you to their contact list, you can't send them chats. That wasn't hard, right? Seems like a really deep and dark problem, but we were able to solve that within moments. Moving on to presence. Is presence real time? Well, the good news is real-time presence is rolling out today throughout all the tenants, coming to your tenant soon. And real-time presence will be real-time or near real-time if both users, both the watcher and the publisher, are Teams-only users or Teams users. We're getting the presence from Teams client. If the presence is being delivered to our service from a Skype for Business client, that story is different. And before I move on to that story, I want to point out that we have a maximum number of subscriptions of 650. If you're a super popular person with a lot of people subscribing to your presence, only the first 160 people get to subscribe to presence. After that, people will need to get your presence through a request versus a push notification. Now, going back to SFB mode users, if a user is homed online for Skype for Business server, the Skype for Business online server will have a direct connection to our SFB interop gateway, and therefore users' presence change can go from the SFB server to our UPS service, the Unified Presence service, and be readily available. If a user is homed on premise, that story changes a little bit because there's no direct connection between that SFB server and our presence service. And therefore, our presence service has to poll for that information, and it does that on an interval of about 4 minutes. We'll definitely see slower presence. That's important for you. If you get reports from users saying, this particular person's presence is not accurate, we'll check to see what that user's homed. If they're an SFB server user, that could be the end of the story there. There's just certain restrictions technologically for that type of presence update. Let's look at this under the covers. I don't have Teams launched here. First, I'm launching a Charles proxy capture because I want to be sure that I have WinSock proxy enabled. So I have, going to the proxy settings, I've enabled SOX proxy because I want to be able to kind of capture that WinSock proxy connection between the client and our service. And you see that we have that captured here on the wire. Let's go ahead and see that traffic. We can see the Trouter service traffic. This is our calling service as well as our presence service. The second entry here is the Teams Unified Presence service, and that's the push notifications for presence to the Teams client. So push notifications are going to come through that WinSock proxy connection from the Trouter service. Now let's go ahead and look at a real-time presence update. Terry is watching, has a chat open with Annie. Annie's going to change her presence. Let's go ahead and have Annie change her presence and see what happens. So Annie's now available, and she's changing her status message to presence is fun. Let's go back to Terry's client and see what we captured on the wire. And you see what we captured on the wire and the time it moved to move from one computer to the other is the presence update of availability, and that presence is fun. And we can see that right there in the card. Real-time presence, super. Now, let's take a look at two Skype for Business users. The first Skype for Business user, Fabrice Canal, he's an online user. Let's see his presence change. He'll go from available to busy. And I have the client open here in a browser. I should point that out. I have it open in a browser, and I'm using a network trace. I could have used the Charles capture, but I want to show you another method. Simply by doing a network trace with the developer tools open, we can view this activity in line with the client. So here we can see that his status changed from busy with that get presence update. Now, let's go ahead and look at another user, Ann Wallace. She's an on-prem SFB user. She's currently away. Let's clear the previous results. Let's request her presence by moving our chat focus away and back. We get her presence, and her presence shows away. Now let's have her change her presence from away to available, right? So she's now available. We've confirmed that. Let's go back and see what happens when we make a request for new presence for this user. Will we get available or will we get away? And you can see the presence is still away, and that get presence status returned away. And that is because this on-prem user does not have a direct connection to the interop gateway to be able to update the service with this information. And that's why we weren't able to see it. Now, we can also look at the diagnostics through downloading the client logs. And we can do various searches. We can do a search for the subscribe presence events. We can do a search for the Trouter presence events for the push notifications. And then finally, we can do a search for the get presence events. And all of this information is available in the diagnostic logs. Again, downloading those logs, using Visual Studio Code with a regex expression, and sending those results out to an editor tab gives you a nice view of all of the events related to the activity that you're trying to diagnose. To recap, real-time presence tracing. If we put a proxy between the client and the service, we can actually view the WinSock proxy or the WebSocket activity live as it happens. For Teams presence subscription updates or get presence updates, that will all be HTTPS traffic to the presence service, which we can view through a HTTPS trace, either through the developer tools or through a third-party tracing tool. And then we can view the events in the MS Teams diagnostics to further analyze those, or if we didn't want to put a trace on the wire. Okay, we finished with our view of how to diagnose some chat and presence issues. And for the rest of today's session, we'll focus on calling. Calling's a big workload, and we're really focused today on direct routing. Because if we think about a service incident, if it's a calling problem on the calling service side, that's likely a service incident, unless we're dealing with issues where the client can't connect to our service through some firewall. And that's, a separate issue. But if all things being equal and everything was working fine one day and the next day something's happening, most likely you're calling support before you're rolling up your sleeves to investigate. We'll start with our calling discussion here on where's my dial pad. Unfortunately, this is an oft-asked question. We have made improvements on both the service side and the diagnostic side. But if you're faced with an issue where a client doesn't have a dial pad where it should, first we need to understand when the dial pad should be available. First, a user needs to be homed online for Skype for Business or Teams. They don't get a dial pad if they're an SFP server user. The user needs to be enterprise voice enabled. This is similar to Skype for Business, right? If they're not enterprise voice enabled, no dial pad. And then the user needs to have a phone system license with either a calling plan, which is business voice, in which case Microsoft provides the call routing logic. Or in the case the user is a hybrid voice user, they need to have an online voice routing policy that where the tenant is providing the routing logic. We don't want to provide the client with a dial pad if there's no route available to route the call, because that would be a bad user experience. So dial pad only lights up when we have the information available to successfully route a call. Let's dive into how we can diagnose this. The good news is that we've added a new tool for diagnosing this right within the support center. Open up a new service request, and then under need help, type dial, just start typing dial, and you'll come up with dial pad missing from Teams. This is a diagnostic that you can run simply by putting the user SIP address. So let's go ahead and run this for a user who's missing a dial pad and see what we get back in the diagnostic results. And what we see here is that the user does not have an online voice routing policy. So we have no way to route that call. We didn't display the dial pad. Let's go ahead and check tenant PowerShell for this user. And sure enough, this just happened to be a tenant admin error. It could be that the policy exists, in which case you would want to dive a little deeper and see when that change was made. If it was just made, wait a few minutes. If it was made greater than a day ago and the dial pad's still not showing, and that was the reason why the dial pad's not showing, you might need to open an incident, or you might want to try nulling the policy and reapplying the policy. I haven't seen problems like that of late, so I'm not sure that would be applicable anymore because we've changed the pipeline. Now, looking at the client that is being impacted by this missing dial pad, we can also download the diagnostic logs and take a look and see what the Teams client determined about this issue. We're searching here on calling support service.star PSTN. And when we zoom in here on this look, we can actually see here that the business voice path is false. That means it's a hybrid voice user. And is BYOT is false. BYOT was our code name for direct routing, bring your own trunk, and it's still used throughout the code. You could have searched on BYOT and found this as well if you knew that code to look on, that word to look on. And we can see that's false. that means the user did not have or does not have an online voice routing policy assigned, which is why we're not showing the dial pad. Now, while we're here talking about calling, one more thing I want to show you. We're talking about policies, and policies are consumed. How do we know what dial plan normalization rules are in place for a client? Well, what we can do is, again, open Teams in a browser, open the dev tools. And in this case, I did a search on dial plan. I could press refresh to refresh the client to pull down new policies, or in this case, I opened the dev tools before signing into Teams. And when I search dial plan, particularly here, we can see this user aggregated settings. Well, that's the phrase we actually want to focus on. I'll clear the search for dial plan. And now I'm going to change the filter to user aggregated settings so that we can look specifically at the settings that were returned for the client. Expanding that first one, going to the policy settings, we actually can get to the dial plan policy and see all of the normalization rules that are in effect for this client that will impact how numbers are normalized when they dial a number from their dial pad. And we can see here details on the calling policy. Focusing just on these policies because that's what we're on here, but you could look at other policies. Right now, we're looking at the policies for a user who has a dial pad, and we can see there that the value BYOT enabled is true. And recap. How to diagnose a missing dial pad. You now can take advantage of our Office 365 support diagnostics for the dial pad, which is super easy. We can also check tenant remote PowerShell to see what the user policy is. Look at Teams diagnostics to see what Teams determined about the decision to show a dial pad or not. And then bonus, use Teams with the browser, with the developer tools, search on user aggregated settings, and then you will be able to see all of the policy settings consumed by the client. Okay, now we have to roll up our sleeves a little bit more and dive into an actual calling issue. Why couldn't that call connect? That's when we start to sweat. What happened? What went wrong? Well, let's take a look. We have a user who's connected to the corporate network. He's a direct routing user, and he's placing a call out to the PSTN. And the call's going out to the PSTN. We see it ringing. We see it connected, and then it disconnected. All right, that tells us something. Let's download the Teams diagnostic logs. Control-Alt-Shift-1, open that up in Visual Studio Code. In this case, we want to search on call controller code. The call controller, the PSTN call controller, is what's responsible for the call controls. And what we see there is the call controller code of 410. Now, you might not know what that means, but you'll learn shortly. If we go over to the Teams Admin Center, there's a great bunch of tool reports over here. And one in particular that you definitely want to put eyes on for direct routing is the PSTN usage reports. And we're going to run that for the date where this call failure was. And we'll go to the direct routing tab. And here we'll be able to see all of the details about the calls inbound and outbound to the service. And you can see over here, call end reason media error for that 410 failure. And we also see that it's a media bypass call. So that's an important fact. Now let's drill further. We can click on the user who placed the call from that report, jump right over to the call history, and get some more details about this call. First, if we look at the advanced calling, what we can see is that the client first certainly had connectivity to our service, but on the SBC side, there was nothing. On the remote PSTN side, 0. If we go to the debug data, we can also see that 410 call media error. And just for an amuse-bouche, show you that you can see the client port range, and there'll be other deep details that you can get in debug. And you can export these reports if you want to for further analysis. Before we leave the Teams Admin Center browser session here, I want to show you CQD PSTN direct routing reports. This is not a CQD session. Matt Wade has a session on that, but I wanted to point out you can use the CQD PSTN reports for other diagnostics, for reliability, for Teams direct routing. And you can publish those to a browser and be able to view them right within the same browser session where you're viewing the other reports from the Teams Admin Center. It can be very helpful. So to recap, diagnose connection failures. We want to search the Teams diagnostic logs for call controller code. We can look at the direct routing PSTN usage reports. We can also look at call history for the user, and that lets us drive into deeper debug and advanced information about the call setup and potential failures. And as a bonus, we can use the CQD PSTN direct routing reports for reliability as well as for call quality. And then we now need to investigate a little bit further. What if we discovered, right? So far in our investigation, what we discovered is the call failed with a media error, that it was a media bypass call, and that the failure was on the SBC side, right? This is not a service side issue. Client was able to connect to the service fine. The client was trying to connect to the SBC, but it could. It's time to dig deeper. Since we know this is most likely an SBC issue, the most likely place would be to start in the SBC logs if you have access to them. So let's start there. Looking at the syslogs, this will show us the traffic between this Microsoft SIP proxy service and the client SBC, customer's SBC. First thing I want to point out here is we see that the user's location is external. That's interesting because they're connected to the corporate network. Why did we not discover them as internal? This customer has configured local media optimization for Teams direct routing, and the user is advising of what their location is, which will inform the SBC of how to advertise to the client for how to connect. It's external, so it's going to advertise its external public IP address. Let's take a look at that in the SDP, and we see the public IP address 40.121.112.155. Now look at the buy. The buy from our service is saying that the call end reason was a media error, right? So SBC was notified of this. We could have started there, right? Now, what if you don't have SBC logs? What can you do? Well, you can do a network trace. You can either install a network tracing tool, which I had on the client, or you could do a NetS trace and then take that captured data to a place where you have a tool installed. We'll see the same thing here. When the client connects to our service, and when we have media bypass story here, SBC informs the service of the client's of the IP address, and the service informs the client. So we see the client trying to connect to the SBC over that IP address of 41.21.112.155. Time to check to see if we have the right information here. So I would propose that what we need to check next is DNS. So let's go ahead and check DNS. And we've checked DNS propagation here against that SBC. And look at the IP address. That third octet has a 111, not a 112. Somebody forgot to update the NAT translation rule when the IP address of the gateway changed. This gateway is sitting behind a firewall, and that is supported, but it requires that the NAT translation rule is updated to provide the correct information over the wire for how to connect to it. Wrong information is not going to provide a successful connection. Okay. I'm taking you to another diagnostic here, and that's the Teams calling logs. These are really helpful logs. When we do a Control-Alt-Shift-1, these logs will also be downloaded. And we can see here the 410 error. We could have started here, but I wanted to show you it also in the other logs. We can see the Teams emergency numbers that were defined for direct routing client, but particularly I want to focus here on the network information. That client's endpoint is unknown. And why is it unknown? Because that public IP address is not in the tenant trusted IP. And when we do a filter against that list, we see that that IP is not there. Now let's take a look at a call from the same user on a different subnet where the trusted IP, the public relay IP address, is trusted. And we can see here that the user location is internal, right? And that's going to make all the difference in the world to the information that's provided in the SDP. So this call would be successful even if the NAT translation rule was wrong, because the IP address in the SDP here for the gateway we can see is a private IP. So the client can connect directly to the SBC over the corporate network, private IP to private IP. Let's take a look at the calling logs for the same call where the user was found to be internal. And particularly we want to focus on that network. And you see there that the endpoint network is trusted. We've identified the user's location. And if you look further, we can actually see the address there, the list location address that was configured when we matched the list location information to the client. We will not do a match against the client list database if we don't trust the endpoint. The endpoint has to be determined to be on the corporate network before we'll proceed with checking other network information. To recap, to diagnose SBC media issues, likely we're going to need SBC logs because it'll be on the SBC side or firewall side. We can do a network trace alternatively at the client side if we can't get to those logs. Use DNS lookup always to confirm your information, because if that IP address is wrong, clearly we won't connect. And be sure you use those MS Teams calling logs. They're super informative. There'll definitely be a log that you want to refer to if we're dealing with emergency calling, or we're dealing with local media optimization, or location-based routing. First rule that has to be passed for a client is we have to identify it as trusted on the corporate network before we'll proceed with looking up other network information. And the diagnostics for that will be in the calling.txt log. One more thing before we wrap up. I'm often asked, how can we view SDP in the client-side trace? Well, what we can do is we can open Teams in a browser, and we can filter on CS proxy on a network trace. And then we can place an outbound call. It has to be an outbound. This doesn't work for inbound. And then when we're there, we can go ahead and expand that response from that CS proxy and look at the blob data, and then copy that blob of data out to another tool for better reading. You can view it inside the trace, but it's not parsed very clearly. If we copy and paste, it'll be parsed. Let's walk through this quickly in a demo. So I have the Teams client open in a browser. I have a trace going for the network. I have a CS proxy filter. I'm placing an outbound call. I'm drilling down to the payload, the media content, and there's the blob. I can see it. I could read it, not so easily. I'll copy the blob out and paste it over to Visual Studio Code. And there you have it, SDP information from the client side. Again, caveat, it only works for outbound calls. If you're doing an outbound call, for direct routing, through a browser client, we don't support media bypass through the browser because we can't make a connection to the through Electron to the network stack. But this could be a useful tool to seeing what candidates the client is offering, to see what might be on the wire that's preventing the right candidate information for a successful call setup. All right. There we have it. Presence, calling, chat. I think we cracked it. We've cracked it open. I hope that you walk away from today's session feeling a little bit more confident on where to start, where to look, how to diagnose issues. You can direct message me for follow-up questions beyond our Q&A today. I can't make the breakout session because I have back-to-back sessions. And here's a link to the survey. Don't forget to fill it out. Thank you very much for joining me today. It was awesome participating in Commsverse, and I hope you're all having a great conference.
Thank you so much, Carolyn. We do have a question that's come in. I suspect that there may be some more questions that come in during this time, but we'll go to David Chomkers first. Is there any official documentation describing the debug and advanced logs, meaning of all the codes and the parameters in the Teams admin portal under user call history, clicking on a specific call?
Have you run into situations where the reason phrase hasn't been available? So for example, in that 410, when I looked at in the direct routing, scroll to the right, the reason phrase was there. Or when we looked at the debug data, the reason phrase was actually there. If you find the reason phrase is not there, we need to fix that. I'd have to do a quick check under plan for direct routing because I believe they did publish some of the SIP codes, but the reason phrase should be in the reporting. If that's missing, let's iterate on that and resolve it. So feedback, welcome. Thanks for the question.
Thank you, that was a great response. I'm just going to leave it open for a couple more minutes to see if we've got any other questions. It was a really good session. I think the pace was so strong that we might just need to wait for people to catch up on the questions. I'm
sorry, I did try.
No, it was great. It was great. It was really good. It was a very in-depth, great session. So if you've got any a few more questions, anybody out in the audience, then please post them now. We'll hang on for a couple more minutes.
Right, and if you're still percolating on this, you can always direct message me.
Absolutely. Okay, we haven't got anything else coming in right now. So as we've said, apologies, but Carolyn has another session directly after this one. So if you'd like to ask her anything, just DM Carolyn using the Teams chat within the Commsverse tenancy, and I'm sure you will get an excellent reply. So all it leaves me to say is thank you very much, Carolyn, for a great session. And thanks for joining us. We hope to see you on the next one.
Thanks all. Thanks, Dave. Cheers.